Okay guys, so here we go with the study guide. Naming the center, that part shouldn't be too bad. You just look for the center of the circle and what point is next to it. So it would be R. That's your center. Name a radius. There's a couple radii here. So one of them would be Rx, another one would be Ry, and then you could even say Rw, so on and so forth, or RT. When we're talking about a diameter, that goes through the center of a circle, so TY would be a diameter. You could even say WX would be a diameter. All right, and then number 4 says name a chord. All right, well the most distinct chord that I can see with 2 points on it would be UQ. You could also say VT was a chord as well. VT. Name a central angle. Right, so its vertex has to be at the center, right? So there's 2 choices here. You could say angle XRY or angle TRW. And then number 6, name a major arc. Don't forget with a major arc it needs to be greater than the semicircle. So there's a lot of choices here. I'm just going to give you one, which would be W to Y, and I'm going to go all the way around to U because I see that that's greater than 180, and I'm going to put an arc over the top of it. Name a minor arc. I'm just going to choose WY because I see that that's smaller than 180, and I'm going to put an arc over the top of it. Don't forget, major arc and a semicircle, both you use 3 letters, and a minor arc you use 2. Name a tangent. Well, here's a tangent line it goes by, so I would say NM is a tangent line, and the point of tangency would be point P. And then a secant, that crosses the circle at 2 places. I would just say NU. NU would be my secant. I guess that has arrows at the end, so that would be a line too. Okay, so moving along. Find the exact circumference and area. Well, I know my diameter's 35 inches, and exact, that's basically like leaving it in terms of pi. So my circumference, which is hard to see, is 35 pi. All right, my area, which would be half of my radius, squared. So area, my radius would be 17.5, and then I would square it and multiply it by pi. When I do that, I would get 306.25 pi. 306.25 pi. Okay, and then it says, given the circumference of a circle is 18 centimeters, solve for the exact area of a circle. Well, what I would want to do is I need to find my radius. So to do that, I would take 18 pi and set it equal to the formula for circumference, which is pi times your diameter. I would divide by pi and divide by pi, and I'd get my diameter is equal to 18. Well, remember your radius, whoops, here we go. Your radius is always half of your diameter, so your radius would be equal to 9. So it wants me to find the area of the circle, and don't forget area is equal to pi r squared. So my radius is 9. I would square 9 and multiply it by pi, and my area would be 81 pi. Okay, next page. Okay, it says given the area of a circle is approximately 452.39 centimeters, approximately, so that means they multiplied pi in it. Solve for the exact circumference of the circle. All right, well, since they're giving me my area, I'm going to set that equal 452.39. I'm going to set it equal to pi times my radius squared. All right, the first thing I'm going to do is divide by pi. And remember, we're not using the symbol this time, so we're going to divide it by 3.14. When I do that, I'll get 144 equals my radius squared. Well, I still need to get r alone. So I'm going to take the square root and the square root, and I'll get my radius equals 12. All right, well, my circumference is what I'm looking for, is equal to pi times my diameter, or 2 pi r. So 2 times 12 equals 24. So my circumference would be 24 pi. Okay, so given the circle below, solve for the measurements of the following arcs. Well, if you notice, these are all central angles. So central angles are equal to their arcs. So if I'm looking right here, and what I would start by doing is I would pencil in the information that I know. So these are vertical angles, so I would pencil in 27 here. And then to find this angle right here, I would take 180, since this is a semicircle. I would subtract 67, and I would subtract 27, and that would give me 86 degrees. Okay, so, and then also for K, or angle K down here, or JKM, I would also take 180 and subtract 27, and I would get 153. So this would be 153. All right, so that when it asks me for arc PN, since it's a central angle, I know the degree of the arc is the same measure, so I would say 86 degrees. Same with RJ, since I was able to solve that that was 27, I would say 27 degrees. And MJ, I know I already solved for that central angle, so I know the arc is also 153 degrees. Now we're talking about NMP. NMP all the way around here. So what I'm going to do is I'm going to do 27 plus 153 plus 27 plus 67, and when I add them all up, I should get 274. 274. I think. Let me just double check that, because, hold on, let me get my calculator out here, and I will just add those up really quick. 27 times 2 plus 153 plus 67. Yes, 274. Okay. My writing on the other copy was kind of messy, so I wasn't sure if that was a 4. Okay, and then NJ. So NJ all the way around. Well, hopefully you see that that's a semicircle, and that would be 180 degrees, which they should have named, put an M in there for 3 letters next time. All right, so we want to solve for X below here. All right, well, we notice that this cuts through the center, so this has to be half the circle. So what I would do is I would do 3x plus 45 plus 28x minus 20 equals 180. I would combine like terms and get 31x plus 25 equals 180. I'd get 31x alone by subtracting 25, and I would end up with 31x equals 155. Divide by 31, divide by 31, x equals 5. All right, so let's go ahead and solve for some measures here. All right, I know this is 64, so I'm going to go ahead and write in that that's 64. All right, I also want to solve for yx here. Yx, which is this entire length. All right. Oh, actually, just kidding. I know that yx is 14. I want to solve for the arc length yw. So yw is all the way from here to here. So I want to find the arc length of yw, which, remember, you guys, you need to take that angle, whatever it is, put it over 360, and then multiply it by the circumference of our circle. Well, since our diameter is 14, I'm going to need to multiply it by 14 pi. All right, and then I need to figure out the arc length for yw, so this whole bit. Okay, well, I know this is 81, I know this is 64, And now I need to figure out this little sliver. I need to figure out that little sliver because right here, this is the area that I'm looking for, right? That's the length I'm looking for. So this is a perfect circle. I'm going to subtract these two from 180 and get 35 for that measure. I'm going to add them together, 81 and 35, and get 116. Okay, so now I'm going to multiply these together. And, of course, I'm having some issues here. Delete 17, okay, so equals 360. When I do that, I end up with, hold on, whoops, 4.51. So your arc length, you can go ahead and write down as 4.51. All right, on to the next one. Ooh. Okay, so right here, this, you can expect to see something like this on your test. It wants you to solve for x. X is right here. Well, if I go ahead and drop down from my center a line to point Q, I've just created a right triangle and a radii. I know my radius is 13. So if I know this is 8 and this is 13 and I want to solve for x, I just created a right triangle. And I can use the Pythagorean theorem to solve for that. So what I would do is I would do 8 squared plus x squared equals 13 squared. All right, 64 squared. Subtract 64 plus x squared equals 69. Subtract 64. End up with x squared equals 105. Take the square root, take the square root. X is equal to approximately 10.2. Okie doke. Let's look at number 18. Well, it's telling you these two arcs are congruent, so you know that these two chords are congruent, and it wants you to solve for x. So you're simply going to set them equal. 9x minus 1 equals 41 minus 5x. I'm going to add 1, and add 5x, and add 5x. I'm going to end up with 14x equals 42. X equals 3. Okie doke. So right here, it wants me to solve for x. So what I'm going to do, there's a couple ways you can do this. The way I'm going to do it is I'm going to take, since I know that these are equidistant, I know that these two chords are congruent, which means I know these two arcs are congruent. So I know that this arc is 10x minus 23 as well. I'm going to take this arc, 10x minus 23, times it by 2 since I know that there's two of them, add 106, and set it equal to 360 because that's an entire circle, all right, 360 degrees. So I'm going to distribute that and get 20x minus 46 plus 106 equals 360. And I'm going to combine like terms, move things over, and get 20x equals 300. Divide by 20, divide by 20, x equals 15. Okay, so there's that. Number 20, moving right along. Trying to not make this the longest video ever. All right, this is an inscribed angle, which means that it's half of the angle, the arc that it's hugging. So that makes this 64. All right, well, if I look down here at this angle, this is 146. So if I divide 146 by 2, that would be 73. Um,